Good morning, students. Today we are starting the bridge course for the students who are just outcome from the 10th standard. In that, some chapters are there, okay, that related to your 10th standard as well as first PUC, first and second both. So in that, the very first chapter is Unit 1, that is some basic concepts of chemistry. So students, you know what is chemistry means in PUC I am telling. So chemistry. Okay, chemistry is the study of chemical reaction which are going to take place in our daily life, in our surroundings, like ignition. Okay, then carbon dioxide is liberated, or burning of petrols in that. Sorry. What is that, hydrocarbons what we are using, okay, vehicles, okay, how the vehicles work, all the things that comes under what, chemistry. In that vehicles, what happens, the petroleum, that is petrol, hydrocarbon burns to give the energy to the engine, so that results in the movement of the mobility of the what, vehicles. In our daily life metabolism, we eat so much food products. In that food products, so many metals are there, iron contents are there, everything is there, right? So in our body inside, water is there, oxygen is there, so many gases are there. They are also undergoes what, some amount of reaction. For example, you know, in our body, whatever the food we ate is converted into what? Glucose. So glucose is a chemical compound consists of C6H12O6. So it is a process. One chemical compound converts into what? Other chemical compound in certain process. So the metabolism in our body, for example, respiration is the, so respiration means intake of oxygen and carbon dioxide, water vapor molecule. Okay. So in that what happens, hemoglobin is the, hemoglobin consists of iron. So that iron has a capacity to bond into oxygen as well as water molecule. So the exchange of oxygen through the lungs is also a one type of a metabolism which takes place by the chemical exchange. Oxygen is also a chemical compound and water molecule is also a chemical compound. Example for that I am telling. Okay. So in our daily life, what we are going to use is all somewhat related to what? Chemistry. So, to study the detailed study of the reactions which were taking place around us, our surroundings, that is called as what? Chemistry. So, in that chemistry, three branches are there. For this, three branches are there. One is physical chemistry, another one is inorganic, another one is organic. Basic. So many types of chemistries are there. Bioinorganic is there, analytical is there, industrial is there. But for your syllabus, PUC, only three are there. One is physical, inorganic and organic. Physical chemistry means which we are going to study about how the reaction takes place, whether it requires a heat, energy or some amount of energy to take place or it releases the energy depending upon that. The feasibility of the reaction is called as what? The thermodynamic study. There we are going to study what? What conditions required to occur the reaction. So in inorganic means we are going to study the history of the atoms. For example, carbon is there. So carbon atomic number is 6. Its configuration is 1s2 2s2 2p2. It is covered in that. It is tetravalent. So that is what? History of the compound. Alright, history of the element. So in inorganic chemistry, we are going to study history of the compounds. Okay. And next, organic chemistry means it is purely carbon and its compounds. Okay, we are going to study only about hydrocarbons for organic chemistry. Okay, so students, in that what we are going to say is chemistry is a branch of science which deals with the study of the compositions of the elements. So in that, the composition of the elements nothing but a matter is. The main thing is here matter. Okay, so this matter is classified in two ways, physical classification as well as chemical classification. Physical classification are right here. Physical classification, this one is chemical classification. So in the physical classification, They are classified as solids, liquids, and gases, and also plasma. Solids, liquids, gases, and plasma. In chemical, they are classified as mixtures and pure substances. Mixtures and pure substances. In that mixture, homogeneous is there and heterogeneous is there. Homogeneous as well as heterogeneous. In this pure substance, elements are there and compounds are there. In these compounds again, inorganic is there, organic is there. So this is the classification of matter. So this is the first thing you are going to remember. So matter is classified into two types: physical classification as well as chemical classification. In that physical classification, solid, liquids, gas, and plasma state is there. In this chemical classification, again they are classified as mixtures and pure substances. The mixtures are homogeneous and heterogeneous. Pure substances are elements, compounds. In that compounds, inorganic compounds and organic compounds. So now I'll first discuss about this physical state. Okay. This is physical state, students. This is solid, liquid, gas, and plasma. Okay, so the solid, liquid, and plasma state is based on what? The arrangement of the atoms. So first I write here arrangement of the atoms. So this is solid means, students, it is a container or a unit volume or a square unit area, you assume. This is gas. I'll take here ice as an example, here water as example, here water vapor as example. First I'll explain this, then I'll explain plasma. Okay, so students, here ice, you know water, water vapor also. Okay, here what happens in the ice, we can have the shape like, so listen, this is a ice. Atoms are H2O molecules in ice. They are regularly arranged in the container. They form what? A definite geometry. If I consider here only 4, it forms a definite geometry. I hope you understood. So here what happens? In solids, the atoms are tightly bounded. There is no much gap between the atom and the atom. One atom and another atom, there is no much difference is there. Okay, so it is arranged in a regular manner, continuous pattern, that tightly arranged with each other to form what? A shape. Okay, so here the solids have definite mass and they have definite shape, and also they have definite volume. I hope you understood, students. Here, in the solids, the atoms are tightly arranged, tightly bonded with each other. So they have definite mass, definite shape, and a definite volume. Okay. Next, if we come for liquid means it is in this manner. Okay. Here, the molecules are arranged somewhat freely. Okay. Compared to solids, the arrangement of atoms here is very loose. Okay. They are not regularly arranged. This is randomly arranged. And they have their definite definite volume, but not, and they have indefinite shape. Okay, students, they don't have mass, they have mass, they have volume, but they have indefinite shape. For example, water is there. If you take water in a bottle, it gets the shape of bottle. If you take water in a container, a square cylindrical container, it attains the shape of cylindrical container. If you take it in this pen, it will take the shape of the pen. So they have indefinite shape. As I told you, the molecules are very freely arranged compared to these solids. Means there is somewhat gap between them. So much force of attraction is less. Means they are unstable. Not unstable. They don't possess that much of attraction. Means they are freely available. Okay. I hope you understood. This is solid. This is liquid. Here we can get a shape. Here we cannot get a shape. But it has mass. It has volume. But it don't have any shape. So if we come to gas phase figures, it is written in. Okay, this is gaseous cycle. Here what happens? First I'll write it has volume. That is definite volume. It has indefinite mass and indefinite shape. So gaseous molecule, students, gaseous molecule means atoms are far away from each other. They are not at all nearer to each other. So for example, carbon dioxide is there, air we are going to see. We can feel the air but we cannot see the air. Right? So in that air so many gases are there. That gases, why they are not visible means, as I told you, the intermolecular distance between these gaseous atoms is very large. They are freely arranged. Okay, that's why it has volume. So we can measure the gases like 1 volume, 2 volume, 3 volume, like that. Okay, 1 mole. Okay, 100 volume of 1000 volume of, like that we are measuring. So they have volume, but they have indefinite mass and indefinite shape. Okay, there is no definite mass and there is no definite shape. For example, balloon is there. If you fill air in the balloon, it will get the shape of the balloon. If any doll is there, we can fill in that. So if we fill air in that doll means it will get the shape of the doll. Okay, so this is what I am telling. They don't have any mass. They don't have any shape. Definite mass and definite shape. This is what solid, liquid, and gas. Okay, so students, here what happens to pressure? Here the pressure will never apply. If we increase pressure, I will say, if we eat this ice, it convert it into water. If we eat this water, it will convert it into what? Water vapor. So if we apply heat, it will change its physical state. If we apply pressure, okay, for example, these molecules are there. Okay, for these molecules, we are applying pressure here means the volume decreases. When the volume decreases, the number of atoms. So these are come nearer to each other. When we compress this, okay, assume here one piston is there. We are moving this towards means after some time what happens? Initially the container is here. Then what happens? So I write this only. Initially container is here. Then you compare another one. When you apply pressure, okay, this plate comes here. Okay, when it comes here, then all the atoms are here. So then what happens, students? Here the distance between two atoms is more. Here the distance between two atoms is less. So what happens here? When we apply pressure to gaseous state, the atoms come closer to each other. When they come closer to each other, then they show the property like liquid. So if we apply the pressure, this gaseous state converted into what? Liquid state. So again, if we apply pressure here, so like this same the way I did, will get solid. If pressure is applied, students, gaseous converts into liquids, liquids converted into what? Solid. So this means pressure cannot be applied on these solids and temperature cannot be applied here. I hope you understood. So how the temperature and pressure works. Okay. So last one is that is plasma state. So what is plasma state? It means it is highly ionized gas made up of almost equal number of positive and negative anions. So for example, you know in gas is there, in the gas so many, in air is there, in that air so many particles are there may be atoms, ions or whatever it may be. Okay. So in this plasma state, we will assume equal number of positive as well as negative ions. When we are going to observe the plasma state, students, in the extreme summer time, okay, sometimes if we are driving the vehicle, so somewhat far distances, at least 5 to 6 meter distance, we'll observe something is flowing like that. Okay, like the water we can observe from the vehicle in the extreme summer days and so in the extreme summer days, what happens? The temperature is at most rate. Okay, the temperature is at a high rate. At that time, what happens? The ions or the gaseous ions or atoms present in the air gets ionized. Ionized to what? One gives equal number of positive and negative anions. Those anions form a mirror-like structure. Okay, mirror-like means we can easily observe it is like a watery. So some distance means we can observe on the road water is there. If you move at the same distance, at the next we will observe water is there. So that is called as what? That plasma state. Okay, it cannot be appear, it cannot be measured, it is visible only in the extreme summer days because when the temperature is very high, then only plasma state will attain. So these are at the room temperature they may attain. Okay, another one thing, so listen, here solid is there, liquid is there, gases is there. At the room temperature, gases are there means their boiling point is less than room temperature. At the room temperature, some are liquids means their melting point is less than room temperature. For example, as I told you, ice is there, its freezing point is 0 to 4 degrees Celsius. So it is liquid in up to 4 to 60 degrees Celsius. So after 60 degrees Celsius, it vaporizes to what? Gas. Okay, so at room temperature means it is in between 4 and 60. So at 25 degrees Celsius, what happens? Water is in its liquid state because the melting point of water is less than room temperature and the boiling point of liquid is greater than room temperature. That's why at above 60 degrees Celsius, it vaporizes to water vapor. I hope you understood the physical classification of matter, solid, liquid as well as gas. Okay, in solids atoms are tightly arranged, in liquids atoms are loosely arranged, and in gases atoms are far away from each other. Here are the properties. Solids, they have different mass, shape and volume. Here they have different mass, volume but not shape. Here they have different volume, not shape and not mass. Okay, this is all about the classification of matter physically. So the next one is chemical classification. Next one is chemical classification. In the chemical classification, first one is mixtures. So what are mixtures, students? The composition of two or more than two compounds is called as what? Mixtures. Okay, so in these mixtures, it is what? Composition of two or more than two components is called as what? Mixture. In that mixture, heterogeneous is there and homogeneous is there. What is heterogeneous mixture means? Okay, right here. Definition. They form, I will say the definition. When the two or more components mixed with each other, they form an uniform concentration. Uniform concentration throughout the mixture. So for example, the students, so mixture of sand and floor is there. Okay, mixture of sand and stone, or a mixture of any two cereals like dal, you may say. Okay, a mixture of rice and jawar. What happens then? They are what? Heterogeneous mixture. They form a uniform concentration throughout the mixture. Okay, for example, and these are separated by what? Separated by physical method. Either by filtration or by anything we can do it. So example for this, blood. Not blood. Example for this is mixture of jawar and rice using. Okay. Next, oil and water. Oil and kerosene, whatever it is. So here what are students? They form a uniform concentration, as I told you. They didn't mix up with each other. In the mixed also, here we can separate jawar, we can separate rice. Here also we can separate oil, we can separate water. So this type of mixtures is called as heterogeneous mixture. In that heterogeneous mixture, we can say types are there. One is suspension. One is suspension. So what is called as suspension means, for example, if you mix a flour, any one of the flour, gram flour is there, okay, maida is there. So you mix any one of the flour with the water and made it into a paste. Okay, so then that is called as what? Suspension, because the particles of that flour is present in the solvent, but they are not dissolved in the solvent. I hope you understood. The mixing of any one of the flours, you may take ragi, jawar, maida, whatever it may be. If it is mixed with water, what you can say? It is mixed, of course, without any lumps, it is mixed. So then what happens? That is called as suspension. They are present in the solvent, in the water, but they are not dissolved in the water. If you keep it that container without disturb for at least 5 to 6 minutes, 5 to 10 minutes, again the flour particles are settled down. Okay, that is called as suspension. So the particles never dissolved in the solution, they mixed up with the solution and we can see them easily. By our naked eye, we can see the flour particle as well as the solvent particle. Okay, I hope you understood. If for this, what is the example? Flour mixed with I will take maida mixed with water. Maida mixed with water. Okay. So second one is colloids. So what are colloids? For this student's example is blood and also milk. You know, in milk, so many vitamins are there, and also protein is there, everything is there, and in blood also, blood, so many metals are there, glucose is there, water is there, it can carry oxygen also, oxygen is there. But if we saw the blood, we will understand only a drop of blood. We cannot see what are the ingredients present in the blood because in the colloids, the size of the solute particles is 10,000 angstrom to 1000, 10 angstrom to 1000 angstrom. Means it is very minute particle. We cannot see with our naked eyes. Okay, it is very micro, less than micro. Okay, 10 raised to minus 10 it is. Micro means 10 raised to minus 6, it is less than micro. So we cannot see with our naked eyes. So what happens in colloids, example I told you blood and milk. In blood and milk so many vitamins, proteins are there, but we cannot see, we just see a white color liquid. In blood also it's like a red liquid. In that we have oxygen, glucose, whatever the ingredients we need or essentials we need for our body. So why we cannot see them? So listen, and the minute, they are very minute particles, very less in their size. We cannot see them with our naked eyes. So that's why they are called as what? Colloids. So they are also heterogeneous mixtures. They never mix up with each other. So these two are the examples of heterogeneous mixture. Types I am telling, suspension and colloid. So suspension and colloid both are heterogeneous only. Solute particles never dissolves in them. But in suspension, we can see them with our naked eye. In colloids, we cannot see them with our naked eyes. Okay. So the next one is homogeneous mixture. Next one is homogeneous mixture. So in this homogeneous mixture, students, it is mixture of two or more components and have uniform concentration throughout the mixture and throughout the solution using throughout the solution or throughout the mixture. Here I am telling mixture means throughout the mixture. This is called as what? homogeneous mixture. For this example is salt solution, sugar solution, etc. Salt solution and sugar solution. In this, students, if salt is dissolved in water, if sugar is dissolved in water, we cannot distinguish which one is salt, which one is sugar. And also at the same time, we cannot separate it. Once the salt is dissolved in water, we cannot separate it until we apply an external energy. Like we have to heat it, and if we heat also, we won't get that much of salt what we dissolved before in the water. So here, students, salt solution is there, sugar solution is there, correct? So in this salt solution, so as I told you, salt is the solute here, sugar is the solute here, water is the solvent here. So they form what? In 1 ml of salt solution you take, or 1 ml of 100 ml of salt solution you take, or 1000 ml of salt solution you take, the concentration remains same. Okay, this is salt solution, this is sugar solution. In homogeneous means throughout the solution the concentration remains same. Okay, this is all about the homogeneous mixture. This cannot be separated by filtration. If you try to filter it, the salt and sugar particle never is separated. All the liquid solution filtered off as a filtrate. Only if the insoluble impurities are there, like in sand is there, like some of other, if that particles are there, they are filtered off, but not salt, but not sugar. Okay, so this is homogeneous mixture. So the next one is pure substances, students. Before that, I'm going to tell the pure substances. I'll repeat it once, and in the next class, I'll explain pure substances and also types of pure substances and types of compounds. Okay, so listen here. In this, I told you physical classification is there. In that, the matter is there. It is physically classified into 3 types. One is solid, another one is liquid, next one is gas, another one is plasma. Okay. As I told you, this solid state, okay, here the atoms are arranged very tightly. Okay, the tight arrangement of the atoms are here. In the liquid means here tight arrangement is there. Here loose arrangement is there. Here very loose. Okay, students, they have different size, mass as well as volume. They have different mass, volume, but not shape. Here they have volume but not mass, but not shape. They don't have different shape and mass. They have volume only. Here they have definite mass, definite volume, but not shape. Here they have different mass, volume, and shape. Another one is physical classification. In that I told heterogeneous mixture. In that heterogeneous, suspension is there, and second one colloids. So suspension means they are heterogeneous mixture. Then solute particles which were not dissolved in the solvent, we can see them with the naked eyes. But in colloids, we cannot see them with the naked eyes. And these can be filtered off with the physical method. Another one is homogeneous. In that homogeneous means they have the uniform concentration throughout the solution. Okay, so this is all about one type of classification. Next class I will explain about the pure substances and its classification. Thank you.